as a representative of the 2010 Jerry Sanders Design Team competition team. I'm going to be presenting on the design for a robot ramrod. I'd like to start by giving you a brief update of what we've accomplished since our last OPR. And this includes the initial design for our end effector. I'll then break the end effector down into subsystems and give you the decisions we still have left to make on that, and then I'll wrap up in the end with the summary. Since Jeff Yates last gave his OPR, we have manufactured and assembled all the pieces of our drivetrain to our frame, and we have successfully turned our tracks both forward and reverse. Additionally, we have decided on initial design for our end effector. Computerized picture is shown here. The blue and cyan ovals are hoops, and circled right here is a piece that will involve alligator teeth. The hoops we're going to use to trap balloons, and the alligator teeth are going to be used to trap strings. Mainly this is going to be for the helium balloons because they're going to be floating in the air. We aren't sure if our hoops will be able to reach the actual balloon part, and we want to make sure that we'll be able to grab all the balloons in the competition. So we're going to implement these alligator teeth to grab the strings by clamping on them. The motion for this can be seen here. And on top of the hoops, we have hooks that are positioned in perpendicular direction. These hooks are going to be used to accomplish the other tasks we have to do during the competition, such as pulling down a hula hoop or opening a trap door. These have to be done to release the balloons for our team. And finally, at the bottom in pink, I've drawn a motor that we are going to use to turn our end effector in the direction in the picture. So I can break our end effector down into 3 subsystems. The first one is going to be the housing. We're going to try and find a lightweight material just to enclose any wiring we might have so there aren't loose wiring hanging out from the end effector. The second is what I would call the arm effector. And this is going to be anything that's going to come into to direct contact with the balloons or like the hula hoop for the other tasks we have to accomplish. And finally, the drive system. Now I told you that to move in the direction shown in the picture, we've decided we're going to use a motor. And that has been decided. We know how we're going to do that. What's undecided is how we're going to move the hoops and the alligator clips like this. The 2 ideas that we're toying with right now are either using a linear actuator that we have in stock. The questions about this is we haven't really done any testing on it or with it yet, so we don't know if it would be able to function in the ways we'd want it to exactly to be able to move the hoops as I've shown you. The other idea we're toying with is to thread a rod and connect it to a motor, and then set a nut in the housing of the end effector. So when you turn the rod will go up and down. On the top of the rod, we would attach the 2 sides of the hoops. So as the rod moves up and down in the housing, when it goes up, the hoops will close, and when it comes down, the hoops will open. So in summary, I've given you a brief update of our major things we've accomplished since our last OPR. I told you, gave you the initial design for our end effector, and then I divided it into subsystems and gave you more details on it. And finally, I told you about the decisions we still have left to make with the end effector and what we're considering for our final design. So I'd like to thank you all for your time right now and ask if there's any questions.
How large are the alligator grips that you're planning to use for the end effector?
Exact dimensions haven't been decided yet, but it'll probably be like, I would say maybe like 4 inches or so.
Are you worried about being able to see that from the side of the rink in order to be able to maneuver it and grip the string?
It is something we were considering, but 4 inches is, that's why we put it at the back, so the hoops will kind of guide the string into it, since the string will be tight because it's tied to the ground and floating in the air. So since the hoop will be shaped in a V, it'll kind of guide the string into the alligator. Or that's the idea, at least. Professor Duncan?
Are you worried at all about the robustness of the hoops? There was a couple robots that used hoops last year, and when they got hit, they could tear the, if just like a strand, right? You know, like a wire hoop, I'm assuming. They could tear it loose and stuff, and then they couldn't score anymore in the ground. And if you're worried about that, do you have any backup plans or for scoring if the hoop got broke?
We don't have any backup plans as of right now, but we haven't, I guess we haven't really considered the robustness of the hoops yet, because we haven't really decided on what materials we're gonna use for, like how we're gonna exactly design the hoops. So we're not sure if we're gonna use, like you said, a wire that would just like connect at the bottom. Is that?
Yeah, I guess my advice would be, don't just think about it working.
Right.
Think about what happens if other robots are gonna be hitting it, you know, you don't wanna, you know, if you can't score, you're done, right?
Any other questions?